In this video, we are going to discuss about velocity analysis. Let's take a rigid body. So this is the rigid body, and this rigid body is in a plane, xy plane, and we have a coordinate system, and with respect to that coordinate system, we are defining the position of this rigid body. So to define the position of this rigid body, we require to define at least 2 points in this rigid body if it's going to move in a plane. Okay, let's call those 2 points as A and B. Okay, now this vector represents a RA, which represents the position of the point A, and the position of this point B is being represented by RB. Okay, these are position vectors, and this vector which goes from point A to point B, which is denoted by RB/A, or like here RB/A, and that's a position difference vector. Okay, fine. Now if with respect to time, if the body moves, okay, if this body moves, then the position of point A could change and the position of point B could change. Okay, so which means RA is going to be a function of time and RB is going to be a function of time. Okay, what about RB/A? The RB/A will change, okay, only if there is a change in the direction. Okay, otherwise there is no change. That's the position difference vector. Okay, so for example, if there is no change in the direction, then the magnitude will also not change, because these 2 points are rigid points in the rigid body, and because of that the magnitude or the length between this point A and B will not change. Okay, so the change will happen only if there is a rotation, and there won't be any change in RB/A vector if there is just a translation. Okay, now so this is a vector, so let's use a vector equation, which is RB, which is equal to RA plus RB/A. So remember the direction, RB, which is equal to RA plus RB/A. Okay, the opposite vector we will denote by RA/B. Right now we are using RB/A. Okay, now let me take a time derivative of this equation, and what do we get? We will get VB, which represents the velocity of point B. Okay, and similarly VA represents the velocity of point A. Okay, that comes from this term RA, and this term we have written as it is. We are yet to calculate what will be the form of this equation, this particular term. Okay, so to identify, let's go to this picture. Okay, and we have told that if you recall, there will be a change in RBA only if there is a change in the direction. So there won't be any change in the motion. For a translation motion, this term will be 0. Okay, therefore we will have a non-zero for that particular term if there is a rotation. So we will take a scenario where it will get rotated, the body will get rotated. Okay, when the body gets rotated, it's rotating in this direction, which means in a very short interval of time, initially this is the RB/A vector and this is the final RB/A vector. Okay, this is the initial one and this is the final one. Okay, the difference is this vector. Okay, and the angle between the new RB/A and old RB/A is del theta. Okay, now with this understanding, let's go to this equation. So delta r, the magnitude of this vector, which is equal to the magnitude of this rb slash a into delta theta, right? So that's what has been written here. Okay, so this r actually represents a magnitude, not the vector. Okay, and what about the omega? Omega is the angular velocity, which is change in angle divided by change in time, and from that definition we can write delta theta is equal to omega into delta t. Okay, now let's take this delta theta definition to here, and what do we get? We will get delta r by delta t, which is equal to rb slash a into omega. Okay, so that's our definition, and that's representing the what is the magnitude of that particular term. Okay, so the magnitude of this particular term, that's actually a vector, but what is the magnitude of this term? The magnitude of this term is this. Okay, so which is what given here. What about the direction? Because we have to associate the direction as well, right? The direction will be, if you see, the direction will be perpendicular to this rb slash a. Okay, if the rotation is very small, then del r is in the direction perpendicular to rb slash a. Okay, and it will be in this direction if omega is counterclockwise, and it will be in the opposite direction if omega is clockwise. Okay, with that understanding, what we could do is we could write this rb slash a or dr b slash a by dt, which is a vector, which is equal to omega cross rb slash a. Okay, therefore this vb, the velocity of point B, we can write it as velocity of point A plus omega cross B slash A, where omega is a vector which represents the angular velocity. Okay, the direction of this omega is perpendicular to the plane. Okay, if it's counterclockwise, then the vector is facing towards us, and if it's clockwise, it's going inside the screen. Okay, so that's the right hand screw rule which we are using. Okay, so that's our equation which represents the relation of relative velocity. Okay, fine. So in the next video we will discuss acceleration. Okay, so the acceleration analysis. Thank you.